Okay, so we're going to look at this topic called partial fractions. I'm just going to read through what the definition of partial fractions is. We're going to see this as like a skill or a thing that we can do that will help us to simplify some problems in the future. It's going to help us do things mostly to do with Chapter 2 functions and things to do with integration and differentiation. Those are the main things we're going to use it for in the future. For now, we're just learning it because it's a thing. So if the denominator is a product of linear terms, I suppose it should say linear rather than alinear, it can be split into the sum of partial fractions where each denominator is a single linear term. So let's just break down some of those things that are written in bold here. It says if the denominator is a product of linear terms. So here's the denominator, and it is a product, a multiplication of two linear terms that we've got here. Then what we can do is we can split it into the sum, or sometimes it might be a subtraction, because remember it could be a negative number as well, of these two things that we call partial fractions. And for now, you just kind of need to know that this can be done. And when we actually do the methods of how it is done, you'll be like, oh, cool, now I understand what you mean. I understand how this works. So just a quick reminder, this identity symbol that we have in the middle, this means that it's equivalent or identical to. It means that these would always be equal to each other for all values of x. But you'll notice I've left the value a and b here because we don't know what a and b are. They are going to be some constant terms. You'll also notice I use capital A and capital B. It's just the standard way that we go about doing this. The numbers that we're looking for A and B, they are going to be capital letters in this particular case that we have. So there's two methods. And I usually, when I teach you a couple of methods, I usually have a preference on which one I like. This one is kind of hard to describe, that I will use a different method depending on what the question is. And so I want you to do both. I don't want you to pick a method and be like, that's the one I'm going to do. I want you to do a mixture of experimenting between them, because some questions, one of the techniques will kind of feel right, and hopefully we'll get a sense of why that's true. So they all start off in this same way. I'm going to begin by writing out what I had over here. So I have 6x minus 2 over x minus 3, x plus 1. And we know that this can be split into a over x minus 3 plus b over x plus 1. They're always going to be, whatever these linear factors are here, they're just going to be repeated, and they're never going to change to something different, okay? Then what I'm going to do is the skills that you've just done for your homework, I'm actually going to add these two fractions together so that I can compare. So when I add these two fractions and compare, I will have a x plus 1 plus b x minus 3 all over x minus 3 x plus 1. You can see that cross multiplication pattern that you will have been practicing in those first two exercises. You can see that coming up again. And so we've now got that 6x minus 2 over x minus 3 x plus 1 is equal to this. So now what I can do, because they have the same denominator, I should just be able to compare the numerators. Agreed? So I can say that 6x minus 2 is equal to a x plus 1 plus b x minus 3. And remember, the aim of this is we're trying to find out what is a and what is b. So this first method is called substitution. What value for x could I substitute in that would allow me to find out either a or b? What value of x could you suggest that would be a sensible one to substitute in that would help? Yeah? Who said 3? Yeah, Ibtiaz, we could substitute in 3. Why is 3 a good idea? Yep. Yep. Good. So if I said that x was 3, this bracket here would be 0, which means b is no longer involved, which means I can find out what a is. So that's a really good suggestion from Ibtiaz, that we're going to say that x is going to be equal to 3 for one of my substitutions. So I'm going to substitute in x equals 3. I'm going to do it on the left-hand side as well. So on the left-hand side, I've got 6 times 3 minus 2, which is 18 minus 2, or 16. And when I substitute 3 on this side, I get 4a. So that means that a is equal to 4. Okay? Now, I could substitute in another number. What other number do you think I should do? Minus 1. Okay. If you didn't do minus 1, you still could find out what b was equal to because you know what a is equal to. So if you said like, you'd have to do a 2 substitution. You'd have to substitute something for x and you'd have to substitute in a. But this is going to be a quick one that will allow you to find out what b is straight away. So if I substitute in minus 1, I would have minus 8 on the left-hand side because 6 times minus 1 is minus 6. Take away 2 is minus 8. This bit is going to be 0, and so I've now got minus 1 minus 3. That's minus 4b, which means that b is equal to 2. Okay? So this means if I was going to rewrite this, I'm just going to say that this fraction that I have is equal to, I would usually do this at the bottom, but I've run out of space, 4 over x minus 3 plus 2 over x plus 1. Yeah. Yeah, of course. Okay? So that's one of the methods with substitution. I'm going to try a different method now, which is comparing coefficients. It's going to give us the same answer that we have at the end. Now, we've done comparing coefficients before. I actually did comparing coefficients with my Year 12 group this morning when we looked at vectors and we did those horrible vector problems where we had to compare the lambdas and mu's. I think I taught you that last year. So we can do the same thing where you can compare the coefficients of things here. I'm going to just go straight to this line that I've got here. We still have to do this process, okay? This process is going to be repeated. I'm now just going to steal this line, and I've got that 6x minus 2 equals ax plus 1 plus bx minus 3. So please don't, you still will have to do these 2 lines that we've got, okay? They're not going to just disappear. And I'm comparing the coefficients. And that means whatever coefficient I have on the x on the left-hand side must be the same as the coefficient I have on the right-hand side.
So could you use these 2 equations to check each other? So
you could use them to check each other. Yeah, you could use them to check each other. I think perhaps the best way to check it is actually to take this answer and add them together and see if you get this.
okay.
I wouldn't do both of these methods. I would probably get my answer, do like you did for homework, and see if you get that. Okay, that's the best way of doing it. Okay, so I'm going to compare the x coefficient. So on the left-hand side, the x coefficient is 6. What will the x coefficient be on the right-hand side? A plus b. Okay, because it's really saying how many x's do we have on the right-hand side. We've got a lots of x and b lots of x. So we have a plus b lots of x. If you need to, I might recommend actually expanding the brackets. So you have ax plus a plus bx minus 3b. And you can clearly see that the x coefficients are a plus b. So that's not enough. I can't find out what a or b is here. So what else should I compare? Yeah, and do you know what I will call that? Do you know what I'm going to write down here? Compare the constants. Compare the constant terms. So the constant term I have on the left is negative 2. The constant term I have on the right is? Good, it's a minus 3b. And then I'll do, with these 2 things, simultaneous equations. Now, you should be getting into the habit of using the simultaneous equation solver on your calculator for speed. You should be able to use this. That's really, really speedy. And for anyone that does further maths, we will be doing versions of this that will have 5 variables. We will have A, B, C, D, and E. So you will need to use the simultaneous equation solver to do this quicker, okay? Or you could just solve them manually. Okay, this is an easy one to solve manually as well. You could just do the top one, take away the bottom one, seeing as we've got a matching part for A. You could do substitution. You could do your calculator. I don't mind how you do it. All I mind is you get the right answer. Okay? I'm not going to use my calculator. I'm actually going to do equation 1, take away equation 2. I'm going to do the elimination method just because I feel like doing something a bit different. So that's 6 minus 2 is 8. The A's will cancel. And b minus 3b is 4b, which gives me that b is 2. And so clearly, you don't even need to do any extra working. You don't even need to write it down. If b is 2, a must be 4. Because of this top line, that a plus b must be equal to 6. And it gives us the same thing. A is 4 and b is 2. Okay? So there's two methods here. Which one do you think is better for this particular question? I think the substitution is better for this question. Okay, we're going to do some examples in the future where I'm going to favour doing the comparing coefficients. Also, you can, if you want to, do a mixture of these methods. Okay, if you wanted to, and some questions might lend themselves to this, you could very quickly find out that a was equal to 4. Let's imagine there was a reason we couldn't do this. You could say that a was equal to 4, and you could also compare the coefficients and say that a plus b is equal to 6, and that would tell you that b was equal to 2. So these aren't like exclusive methods. You can use the techniques together. They're just all the same techniques that will help you to do this. So we're going to try another question, yeah? So this one's a bit trickier because we've now got 3 different things that are happening. I've got 6x squared plus 5x minus 2 over x brackets x minus 1, 2x plus 1. And I know that can be split into 3 partial fractions this time. So 6x squared plus 5x minus 2 over x, x minus 1, 2x plus 1 is equal to... Now I wonder if we can start adding them together straight away. So what am I going to have to multiply the a part by? X minus 1, 2x plus 1. The b part is going to need to be multiplied by an x and a 2x plus 1. And the c part is going to need to be multiplied by an x and an x minus 1. And then obviously that common denominator is x, x minus 1, 2x plus 1. Now, if you're really strapped for time in the exam, you probably wouldn't want to write that line out again, would you? So if you want, you could just cross through these on both sides. I'm going to just write them out again because I'm doing my formal notes here. Because I just like seeing it looking as neat as possible. And we'll start off by doing the substitution method. And we're going to do both methods, okay? Someone just tell me a value I can substitute. Arisa, could you tell me a value I could substitute for this? We could substitute, oh, careful, I don't think it would be a half, almost that. Minus a half, yeah. If we think about this one here, if we want to make this thing equal 0, x would be equal to minus a half. So we could substitute x equals minus a half. And so this is why maybe a substitution can get a little bit more complicated, okay? So if I do that x is equal to minus a half, let's substitute it in here. Okay, well, minus a half squared is a quarter, and 6 quarters is 3 over 2. 5 times minus a half is minus 5 over 2. Minus 2. So you don't really need a calculator, but... And which of these terms are going to disappear? The a is going to disappear, yeah? Anything else? And b is going to disappear. So we're now just going to have this bit, which is going to be equal to c multiplied by minus a half multiplied by minus a half minus 1. So 3 halves minus 5 halves. Obviously, you could put this all on a calculator. I'm just being, I was going to say lazy, but it's not lazy. That's it's the opposite of lazy. So that's minus 2 over 2, which is minus 1. So it's minus 1 minus 2, which is minus 3. And then this, you've got minus a half multiplied by, this is minus 3 over 2. Positive 3 over 4. It's 3 over 4c. Again, you can just get speedy with typing things in your calculator here. So I'm going to multiply by 4, and then I'm going to divide by 3. So c is equal to 4. So that was one of the things I substituted. Arisa, thank you, because you actually did pick the hardest one first, okay? But it doesn't matter, because we were going to need to do them all anyway. What's going to be a really easy substitution? I think there's something easier than 1. 0, okay? 0 was the one I was thinking you might have said first of all. Because if I substitute in 0, that's going to be so easy, and that's going to just disappear. So if I substitute in x equals 0, the left-hand side is minus 2, and I just get, these are going to disappear, so that's minus 1 times 1, which is just minus 1, so it's just minus that. So a is just equal to 2. And then the last one I should substitute in is the other one that you guys suggested, which is 1, which is also going to be really easy. So it's just going to be 6 plus 5 minus 2, which is 9. And then this is going to disappear, and this is going to disappear. So I've got b times 1 times 3, which is 3b. And so b is equal to 3. Now I'm going to write out the final answer at the very end. I'm going to do both methods, and then I'm going to write out the final answer. If you don't write out the final answer, you wouldn't get the marks. Yep. So you do need to make sure you write out what the final answer actually is at the end of your question. But we're going to do the other method, which is going to be the comparing coefficients. Some people, when I did this with students last year, some people were just amazing at comparing coefficients, and some people were just terrible at it. So when I say which method, it's also which method kind of like sits well with you as well. So I'll do this one in a different color. So I'm going to say I'm going to compare the coefficients. First of all, I'm going to compare the x squared coefficients in this that I have here. And I can try and do it without expanding, because it's actually not that difficult. So the x squared coefficient on the left-hand side is 6. How many x squareds would I get from this? 2a. Yep. So I'd get 2a from this bit. How many x squared coefficients from here? 2b. And here, c. So you're going to have 3 unknowns this time, okay? When we do this in further maths, this is basically going to be the only way you're going to have like lots of equations. You're just going to use the equation solver. But you've got simultaneous equation solvers on your calculator. So this one's going to be a bit trickier when we compare the x coefficients. So it's going to be 5 on the left-hand side. First of all, how many x's would we have here? Minus a, because you would have minus 2x plus x, which is minus x, so that's minus a. And the x's that you would have here, you're going to have 2x squared plus x, so it's just going to be plus b. And the x's that you have here, minus c. And then the last one that we compare are the constants. So we're going to have minus 2 equals, what constants would we have? Minus a. No constants in this one. No constants in this one at all. So again, it does feel like there's a lot more work in this one, but in the future, I'm going to show you some examples where comparing coefficients is better. If we know that a is minus 2, we can now substitute it in here and here, and we could then do simultaneous equations and keep going. If you have got the big graphics calculators, I think the normal calculators as well also do 3-way simultaneous equations as well. You could also use that to find them. I think you're going to want me to do this, so I'm just going to finish it off. So if I substitute in a as 2, I'm going to substitute it in here. So if a is 2, this would be 4. And so 6 minus 4 is 2. So I get that 2 equals 2b plus c. If this is minus 2, I'm going to put it to the other side, so I get 7 equals b minus c, like this. And then I'm going to take this equation and this equation, and I can add them together because the c's will cancel. So I get 9 is 3b, so b is 3. And if b is 3, then c is negative 4. I think you'll agree with me that the black method in this one is more demanding. But I'm showing it to you a few times, like I've said a couple of times already, because it will be more useful in some of the examples that we do, okay? Now, I haven't quite finished this question, so I should have said, so the blah, blah, blah thing is equal to, I'm being so lazy, I'm sorry, is equal to 2 over x. B was 3 plus 3 over x minus 1. And then it's going to be minus 4 over 2x plus 1. I just couldn't be bothered to write out the fraction at the beginning. So you'll see at the bottom half of that page now, you've got a question that you can have a quick go at, and then we're going to do some practice from exercise 1D. Okay? So this is the question I'd like you to have a quick go at, and then we'll do some from exercise 1D.